In this section, we will talk about the difference quotient of a function f at x, which is given by the expression f of x plus h minus f of x all over h. Here's an example. Given that f of x equals to 7x plus 3, we want to find and simplify the following three expressions. Let's start with f of x. We will take the difference quotient and we'll break it up into three parts. The first part being f of x, the second part being f of x plus h, and the third part putting it all together. So let's start with the easy one, f of x. Well, we know here that f of x is 7x plus 3, so there's not much work to do there. Next, let's find what is f of x plus h. Now remember that the parentheses contains the input. And whatever the input is, the x in the original function f of x, the x gets replaced with the input that is in the parentheses. So we know that f of x equals to 7x plus 3. And think of the x as a placeholder. Okay, so it's a placeholder for the input, and it's going to get replaced with whatever input is in the parentheses. This is going to replace every x you see on the right side of the function. So in this case, instead of saying 7x, our input is x plus h. And remember, this x gets replaced with whatever is in that parentheses, which is the input. Since our input is x plus h, this x is going to get replaced with x plus h. So instead of 7 times x plus 3, we have 7 times x plus h plus 3, which we can simplify to 7x plus 7h plus 3 if we distribute the 7. Now I'm going to put a parenthesis around it because we will need it later. So our expression f of x plus h is equal to 7x plus 7h plus 3. Now let's put all of it together. From part B, we know that f of x plus h equals to 7x plus 7h plus 3. So in parentheses, I'm going to put 7x plus 7h plus 3 minus f of x. From part A, we know that f of x is equal to 7x plus 3. The one thing that's super duper important is anytime you replace the f of x plus h or anything with an equivalent expression, you have to always use parentheses. And we are going to divide all this by h. Okay, let's keep simplifying. So you got 7x plus 7h plus 3. I'm going to rewrite that just the way it is, but the second parentheses has a negative sign in the front. So we distribute the negative. That gives you a negative 7x minus 3. And all of that is divided by h. Okay, let's keep simplifying. We have a 7x and a negative 7x. 7x minus 7x. So the 7x minus 7x, that's going to add to 0. You have a positive 3 and a negative 3. That is also going to add to 0. So let's take a look at what we have left. All we have left is the 7h, and we're going to divide that by h. 7h divided by h is equal to simply 7. So the difference quotient of f of x equals 7x plus 3 is 7 at x. And anytime you see this expression, the difference quotient, it is always going to be f of x plus h minus f of x divided by h, which means we will have to follow these three steps. Let us take a look at another example. This time, our function f of x is a little more complicated. It's negative 5x squared plus 2x. We want to find and simplify the difference quotient. So let's break this up by parts. Remember, the difference quotient is f of x plus h minus f of x divided by h. And we will break this up into three different parts. This is part 1, this is part 2, and all of it together will be part 3. So part 1 is an easy one. F of x is simply equal to negative 5x squared plus 2x. Now for f of x plus h, your input is x plus h. So in the original function, negative 5x squared plus 2x, every time you see an x, it is going to get replaced with the input. the input always replaces the x's in the original function. So instead of saying negative 5x squared, I'm going to replace the x with x plus h. So I get negative 5 times x plus h squared. Notice what's happening. Instead of x squared, that x gets replaced with the input, which is x plus h. Instead of 2x, we are going to replace the x with the input. These x's always get replaced with the input in the parentheses. Now it's a matter of simplifying. So a quick reminder that anytime you square an expression, you have to write that out twice. So we have negative 5 times x plus h times x plus h plus 2 times x plus h. Now we will distribute. So we have the negative 5 on the outside. We have x times x, which is x squared. Then we have x times h, which is plus xh. We have h times x, which is also xh. And then we have h times h, which is h squared plus 2 times x plus h. So we distributed, we FOILed these two expressions. Now we combine our like terms. So we're going to add x plus h times x plus h. This gives you a negative 5 times x squared plus 2xh plus h squared plus 2 times the quantity x plus h. So from the beginning, I took the x plus h squared and I wrote that out twice. And then I distributed. X times x is x squared. We got xh, we got another xh, and we have an h squared. Then I combine my like terms. Then I need to distribute the negative 5. So we have a negative 5x squared. Negative 5 times 2, that's a negative 10xh. Negative 5 times h squared, that is a negative 5h squared. 2 times x is 2x, and 2 times h is 2h. So this expression here, that equals to f of x plus h. So now in part 3, let's put all of it together. F of x plus h is that expression which we just found. And anytime you replace f of x plus h or f of x with the equivalent expression, we always have to use parentheses. So this equals to parentheses negative 5x squared minus 10xh minus 5h squared plus 2x plus 2h minus f of x. Well, what's f of x? That's equal to negative 5x squared plus 2x. And then we will divide this all by h. Let's start simplifying. The first expression stays the same. We got a negative 5x squared minus 10xh minus 5h squared plus 2x plus 2h. Here we distribute the negative. So this gives you a positive 5x squared. Negative times a negative is a positive. And a negative times a positive will be a negative 2x. All of that is divided by h. Now let's simplify. Let's take our like terms and add or subtract them. So we have a negative 5x squared and a positive 5x squared. We have a positive 2x and a negative 2x. Here's how you know that you did it correctly. You know you did it correctly when only the h's are left and everything else is going to add to 0. Okay, so if I look at the terms that are left over, it's a negative 10xh minus 5h squared plus 2h. So I know I'm doing it correctly because only the h's are left. So we have a negative 10xh minus 5h squared plus 2h. And the whole thing is divided by h. So what I'm going to do is I'm going to individually divide these three terms by h. So here the h divided by h is 1. That gives me a negative 10x. Here h squared divided by h, you have two h's and you take away one of them. So that's a negative 5h. And here the h divided by h is 1. So that gives you a plus 2. And this is the difference quotient. I know this is a hard concept, so we're gonna of course go over this in class. We'll review it more. And this next example we will work on in class. But please come prepared with questions on this, things that you don't understand that I can clarify.